This is a video for Chapter 5, and in this video I will discuss another continuous probability distribution, and this is the uniform distribution. This is discussed in Mendenhall in section 5.4. The idea here is that not all continuous distributions are bell-shaped. Okay, and this would be what I want to discuss is the uniform distribution. There actually are many more. We'll encounter some of them in later chapters, but I just want to show you one right now. This is the uniform distribution. It means that all values between two extremes are equally likely or equally probable. So what is a graph going to look like? Well, there isn't one that particularly stands out, so it looks like this. So here would be your y values, and this is the probability density again on the y-axis, and it's a continuous distribution. So if this is restricted to two values, it can't be infinite like with the bell-shaped curve. So you have two values here called the lower one a and the upper one b. The probability is equally likely, then this is just a straight line. Okay, so what is the actual probability between say this value, which I'll call C and D? It's the area under this curve, which is just the area of that rectangle. So what is the height of this probability density curve? Well, remember that the total area under here has to be 1. So if the area is 1, the height of it has to be 1 minus b over a. B being the upper value and a the lower. So to check that, what's the area, which is a probability that y lies between b and a, you would take the height of the curve, which I said is 1 minus b over a, times this length here, because you're just getting the area of a rectangle, so that's b minus a. Those cancel and the answer is 1. The mean of it is just the average. Okay, here's just an example. Say you find that you lost your cooler, which somebody didn't tie down, right? Somewhere between mile 35 and mile 97 of the Sterling Highway. And there was no one particular location that was any more likely to lose that cooler than the other. You have a uniform distribution. So the height, so what we have here is we have B is 97, A is 35. What's the height of that line? It's 1 over b minus a, so it's 1 over 62. Okay, and y is limited to this, to 35, mile 35 and mile 97. Right. The mean is just the average. It really doesn't have a lot of meaning, except you say, well, that's the average place along the road, halfway along. Right. What's the probability the cooler was lost between mile 37 and mile 40? That would be the area. Let me show you what that looks like on the graph. So here's a graph of the situation. All right, this is 35. The end of this is at 97. It's a uniform distribution. The height of this bar is 1 over 62. All right. The total area under here is 1 because the cooler was lost, so the probability is 1 that the cooler was lost somewhere between the time you last checked it and the time you discovered it was lost. If you want to know the probability between two particular locations, and we're looking at 37 and 40, that probability is the area of this rectangle. So to find the area of this rectangle, you would take the height of the rectangle, which is 1 over 62, and you'd multiply it by the base, which would be, okay, so you got 40 minus 37, because that's the width right there, which is 3. So you didn't put 3 over 62, and that would be the area under the curve. Just like with the bell-shaped curve, the area under the curve for these continuous distributions gives the probability. So that's a uniform probability distribution.